Hello gems, welcome back to another video. This is the grind for BITSAT 2025 and today we are rolling in the waves, which means we will be discussing the chapter of waves from your 11th standard. If you have followed this series through and through, kudos to yourself, give a pat on yourself because you have completed your 11th standard question bank series completely. Okay, this is the last chapter from 11th standard, so kudos to you on completing it. We'll complete it in this video, of course, and you can check out if you have missed out the previous video. The playlist will be available in the question bank series playlist will be available in the playlist section. So by now you know the drill. Firstly, we discuss the previous year question trends. We see which topics among this chapter are being frequently asked for BITSAT, and we have a focused question discussion later, about 10 questions to get stronger in this particular topics, right? So in February, so basically in Jan we have ended up our 11th standard. In February I'm planning to start with your 12th standard question bank series. We'll drop more content for BITSAT 2025, not related to question banks also. I'll drop a strategy video as well. So if you're somebody who is looking out for that, check out this channel in February, okay? So let's discuss the previous year question trends. So 8 questions from resonance. So basically question based on open and closed pipe will be coming to those type of questions. Then questions based on wave equation. So equation of wave is given, maybe finding the phase velocity and on, right? Then we have Doppler's effect, one of the most important topics for your BITSAT. Okay, I've been saying this since 2021. Okay, it's quite a important topic for BITSAT. So however, we won't be discussing it in this video. It's an important topic and deserves its own video. So I've previously made a video on Doppler's effect, and I've also explained the concept over there, how to choose the signs in Doppler effect, and I'll link that video in the description. I'll also would have done questions over there, so you can get overall hold on this topic. Then finally we have final 2 topics are speed of sound, 3 questions on that, and waves on string, wherein you place a string with certain tension. Okay, so you have waves on string. Okay, so that concept also we'll practice about in this video. Okay, so that's about the previous year trend. Okay, and we'll move on to the questions now. So question 1 and 2 to kick things off today. So in question 1 we are given the equation of wave. This is a wave on a string, linear mass density given. You are supposed to tell the tension in the string. Now looking at the equation, you can actually find the wave velocity, right, omega by k, and you also know this is a wave on a string, so its velocity is under root t by mu, right? So you relate this two concepts. One is speed from this equation and the speed for wave on a string, right? So from here you can find t easily. Now what is omega? Now this equation you can compare it with a sine omega t minus kx, right? It is of this form. So you can find omega by k. So omega will be the coefficient of t. So omega is 1 divided by 0.04 and seconds. This is in the SI unit. Okay, and take a note that the coefficient of t is 1 by this, right? It is in the reciprocal, not in the numerator. Okay, so be careful about that. And here the coefficient of x is k. So k is 1 divided by 0.5, and this will be under root t by mu is 0.04. Okay, so you can square this on both the sides, but before that I can solve this. So it will be 0.5 divided by 0.004. So I'll multiply it by 100. So 50 by 4, right? So which is 25 by 2. Okay, so this is basically 25 by 2. So 25 by 2, you square it on both the sides. Right, this is 25 by 2, and I'm squaring on both the sides. So this will give me t and 0.04. So t will be basically 25 into 25, and we'll have 4 into 0.04. Right, so this cancels 0.01, and 25 square is 625. So 6.25. Right. So shift to decimals. So option D, 6.25 is the correct choice. Let's come to this one. Here we are supposed to tell about the sound. Okay, speed of sound in the medium is v. So speed of sound, you'll know the Laplace correction to the speed of sound. So speed I can write it as gamma p by rho. Right? For Newton it was p by rho. Here we can write gamma p by rho. Okay, so if the density of the medium is doubled, keeping the pressure constant, this is important statement, pressure is constant and the density is doubled, so you can see that this is directly related to 1 by rho, right? Pressure is constant, gamma will be constant. It depends on the degree of the freedom, right? Gas is not changed, gamma won't change. So you can see your speed of sound depends on 1 by rho. Okay, so what will be the new speed if the density of the medium is double? So rho dash is 2 times rho. Okay, so this is, I can say s. So s dash new speed will be somewhat like this. So 2 times of rho, right? So which is 1 by root 2 of your, now this you can write it this way, okay, and this is nothing but s, right? This part is s since it's proportional. When you take the ratio anyways it will get cancelled, so you'll have a root 2 factor. Okay, so here they have used v, so the original speed by root 2, so original speed by root 2. Okay, or if you're confused in this method, so s you know this way, right? So this is the for medium 1, so s1 I can write, and s2 will be gamma p by 2 rho, right? You can take the ratio. Let's take s2 by s1 since we want to find s2. So you see gamma p by rho gets cancelled and you'll have the root 2 rho. So for this inverse relation, and this will come on top rho, this and this gets cancelled and you are left with, so s1 can go on the other side, so s1 by root 2, right? So if you are confused by this direct proportionality method, you can take the ratio, right? So you do the math and you get the answer as this proportional to the original speed by root 2. Okay, so that is the answer over here. One more question to you is, what will happen if we double the pressure? Okay, the actual question is, does speed of sound depend on pressure? Okay, this is a tricky question. You tell me the answers in the comment section and justify your answer. Okay, so that will make me happy. I'll give you a heart. So that's about these questions. Over to the next one. Come to question 3 and 4. In question 3, again we have two wave equations. We are supposed to tell the phase difference between them. Okay, so if you compare, you see 100t is same, x by 50 is same, so this should be the phase difference, right? Or see for this also, so it is sine and cos, right? So they in fact differ by a phase of pi by 2. Okay, so y2, I'll bring it in terms of sine only, since you can only compare sines with sines. Okay, apples with apples. So sine, you can write cos as sine pi by 2 plus theta, right? In the second quadrant, sine is positive, so pi by 2 plus theta will be cos theta. Sine pi by 2 plus theta is cos theta, right? So I can write this cos as sine pi by 2 plus this theta, entire thing, right? 100t plus x by 50. Okay, now it's in standard units, x is in meters, t is in seconds, so you'll get the answers in radians. Okay, the phase difference. So basically, now what is the phase difference? So this is the phase, right? The part that is in the argument of sine, so that is the phase. So this is y2, phase of y2, phase of y1. Just see the difference, right? So 100t common, so basically subtract the two. Okay, so this and this will get cancelled, this and this will get cancelled, so you'll have so basically I'm subtracting this from this. Okay, so you'll have pi by 2 minus 0.5, right? Pi by 2 minus 0.5. This is the only difference. The rest of the terms are same. So this is around 1.57 minus, right? Pi is 3.14. So by 2, 1.57 minus 0.5. So 1.07 radians, which is option D. Okay, in the standard units, SI units. 4, we have closed and open pipes, and their first overtones are matching. So the first overtone for the closed pipe is matching that of the open one. Okay, by this I mean the first overtone. Okay, so you are supposed to tell their lengths will be in the ratio. Okay, now I hope you are well versed with the concept of overtones, harmonics and all of that. Okay, so if you're not, I have a video dedicated to that as well. So if you confuse with which overtone is which harmonic and which is for closed pipe, which is for open pipe, so that is causing confusion, go and watch that video. Okay, I'll brief it up over here. Okay, you won't, if you get lost somewhere, please go and watch that video. Okay, it will be quite helpful. This type of questions, you saw it in the trends, are important for BITSAT. Right now for open pipe, all the harmonics are present. Okay, so the first overtone will be 2 times its fundamental frequency. Okay, I'll write fundamental. Okay, so for open pipe, all the harmonics are present. So basically, the first overtone is the next one, right? So second, 2 times of fundamental frequency. Okay, then we have for closed pipe, which is closed at one end, not at both ends. Then we cannot have resonance. So closed pipe, which is closed at one end, basically you'll have only the odd harmonics present. So it will be 3 times the fundamental frequency. Okay, now these two fundamental frequencies for closed and open pipe are also different. Okay, you have to pay attention. So here for open pipe, basically I remember it this way, that open pipe, it's open at both ends. So there is higher oscillation, right? High chances of oscillation, or you can see greater frequency. So you'll have anti nodes at both the sides. So here in this case, here you'll have anti node on one side and node on the other, right? Because this is closed. Okay, so here you'll have anti node on both the sides. So clearly you can see the frequency is more over here. So what I say is this is V by 2L, okay, and this will be V by 4L. Okay, so the closed pipe will have a smaller fundamental frequency than the open pipe. Okay, so closed is smaller, right? Open is larger. So that's how I remember it. Now let's solve it. V will be same, speed of sound, and what have we got over here? So you can cancel this and this 2 times, and this is for closed and this is for open. Okay, we'll take the ratio of closed by open. That is how it is mentioned in the question. However, for this question it won't cause any issue because you don't have 2:3 and 3:2. Okay, those type of options are not that. But remember, in generally for a certain type of questions, that whatever is the order in the question, that is the way you take the ratio. Okay, so now this will be LC by LO, right? So LC by LO, this 2 comes over here, so it is 3 by 4. Okay, so option C, 3 by 4 is the correct choice over here. So over to the next question. Question 5, this you can do with a little bit of logic. Okay, no physics required over here. So if you see, the person is standing between 2 parallel hills, not so parallel. So let's draw some hills. Okay, so this person will fire a bullet. He hears an echo after t1 seconds from, so suppose he hears, suppose the distance is d1 over here from this hill and d2. Okay, that is what we are supposed to find, right? The distance between the two hills. So d1 plus d2. Okay, so he'll fire a bullet. Suppose he hears echo first from this. Okay, in t1 seconds, and then he hears echo from this. Okay, in t2 seconds. Now echo is reflection of sound, right? So if you see, first the echo will go from here. Okay, the sound will go from here to here. Okay, hit the hill and come back, right? That is echo. So t1 is what? Time is equal to distance upon speed. So this is d1 plus d1, right? So 2d1 by v. Okay, time is distance by speed. So the echo that he's hearing after t1 seconds is this, right? The sound has traveled d1 distance and then d1 back, right? So 2d1 by v. Okay, so they have mentioned parallel for a reason. So it's like this. Okay, so 2d1 by d. Okay, here also, just to be accurate. Okay, so sound will go and come back. So t2 will be 2d2 by v. Okay, of course speed of sound is same in both the directions. So how we are going to find d1 plus d2, right? That is what we are supposed to find. So just add these two equations, or I can add it this way. Okay, vt1 is 2d1, vt2 is 2d2. Okay, just taking this v to the other side. Now you can add. So v plus t1 plus t2 is 2, and that you can take common, d1 plus d2. Right? So d1 plus d2, you can write it as d, distance between the hill. So v t1 plus t2 divided by 2. So basically the average of the time, right? V into average of time, which is option D. Okay, so that was the simple logic behind this question. No such concept of waves, only that echo is reflection of sound, right? So that's about this question. Over to the next one. Question 6 and 7. In question 6, we have amplitudes of 10 micrometer, 6 micrometer, 7 micrometer. They are arriving at a point, suppose point P, okay, and with successive phase difference of pi by 2. Okay, so suppose 10 appears at p first. Okay, so they are appearing successively, right? Uh, 4 will appear by a phase difference of pi by 2, which is this. Okay, then the 7 will appear again with a phase difference of pi by 2. This is 90, right? Pi by 2 is 90, so 7 will appear like this. So pi by 2 and 7 again with a pi by 2. Okay, successive pi by 2s. This is what they mean. You are supposed to tell the resultant amplitude. Now this is easy, right? 10 minus 7, because basically they are not vectors as such, but you can treat them, right? So you have the amplitude formula also. Okay, so that is basically close to your vector relations, like addition of your vectors, right? So 10 minus 7 will be 3. In which direction? In the direction of this 10, right? And then we have 3 and 4, right? So this is 4, 3. So resultant of 3 and 4, Pythagoras theorem, it is 5, right? So the resultant will be 5. Okay, so you can use Pythagoras over here, right? So 4 square plus 3 square, okay, and under root of that. So 25 under root, which is 5. So this is the result. I'm using this Pythagoras because this is 90 degrees. Otherwise you use the addition of vectors, right? So a1 square plus a2 square plus 2a1 a2 cos theta. Okay, so here the theta is 90 degrees, right? Cos 90 is 0, so this factor goes out, and basically you boil down to your Pythagoras theorem. Let's come to this one. Here we have a cylindrical tube. It's open at both the ends. Okay, the fundamental frequency is f naught in this case. Now you know fundamental frequency of an open pipe at both ends. It's larger than a closed pipe at one end, so it will be this, right? Suppose it has length L. Okay, now what we are doing, we are dipping this tube. Half of its length is dipped within the water, so effectively it's rendered useless. Okay, this L by 2 is useless, so effective length now becomes L by 2. Okay, half of the length is in the water, so basically you'll have the vibration in the air column only in this L by 2 section, right? You are supposed to tell the fundamental frequency of this pipe. Okay, so we'll call it F. Now this is a pipe which is closed at one end, right? So this has a fundamental frequency of V by 4N, right? Because for a closed pipe it is lesser. Okay, so it is 4L, and keep in mind that this is half. Okay, the length is half, so basically you'll see that it is V by cancel this 2 2s are, right? So V by 2L, which is equal to the open pipe with length L, right? So you have basically done two counteractive things, right? So one, you have half the length, and then you have made it closed at one end pipe. Okay, so basically those two are counteracting, and you have fundamental frequency same as the original pipe, which is option B. Okay, so that's about these two questions. Over to the next one. Question 8 and 9. In question 8, we are given a string which is fixed at one end. Okay, it's fixed at one end. It's a string, it's a wave on a string, right? So it is open at one end. So you can treat it analogous to your pipe which is closed at one end. Okay, you know here that, so here basically you are supposed to tell what will be the resonant, so it resonates in different modes. So you are supposed to tell the ratio. Okay, so I told you for open pipe, only the odd ones are present. Right? So the logic behind this, if you see, is the antinodes and nodes. You see that make the nodes and antinodes, use F is equal to V by lambda. Okay, and lambda you can express in terms of L. Okay, and you'll have the results that we have for open pipe. Okay, and similarly you can relate this analogously to your string. Okay, so I told you for odd, for this one, for closed pipe at one end, so you'll have only the odd harmonics, right? Meaning you'll have F1 as, so your fundamental frequency will be V by 4L, right? And then it will be 3 times V by 4L, and it will be 5 times. Only the odd ones are present. Okay, so 1, 3, 5. Okay, and here also the case will be the same, only the V will change, right? V is actually T by mu over here in this case of string. Okay, on a string. So here it is velocity of sound in air, but here um, it will be the velocity on the string, okay, which is under root T by mu. But anyways, since we are taking the ratio, we are only interested in this number, right? So 1, 3, 5. So similarly, it will be 1, 3, 5, 7, 9. Only the odd ones will be present since the string is tied at one end. It's analogous to a pipe which is closed at one end. Okay, so let's come to this question. Here we have a string again, and we observe two resonant frequencies, this and this, and there is no resonant frequency between them. So they are consecutive, right? So F, so you can see that it's stretched between 2 points and it's fixed at the 2 points, right? So it is like a closed pipe. Sorry, it is like a open pipe. Okay, so you'll have NT nodes at both the sides. Okay, so it's fixed at both the ends. So just like an open pipe which is open at both ends. Okay, so fixed you can relate it to open. Okay, so node and NT node, you will see the relation there. Okay, anyways, this is related to this is related to this. It's open at one end. Okay, so here successive frequencies, right? So this is one and this is the next one. So suppose I call this one, so the smaller one 315, I'll call it Fn. So some L, so for some value of n, this is set aside. This will be 350, okay, and this will be 2 by L, right? So for an open pipe, like or a string, okay, you can relate those two alike. And the next one, so n plus 1, right? This is open string, open pipe, which means the string is fixed at both the ends, meaning all the harmonics are present. So 1, 2, 3, 4, so n will be n plus 1. Okay, next one will be n plus 1. So if this case was about a string that was fixed at one end, so then the case would have been different, right? This would have been n plus 2 and we'll have 4l, okay, because only the odd ones are present in case of this type of a string. Okay, now you know this. How can you find the lowest frequency? Now this is a very typical type of question. You can take the difference, right? N and n will get cancelled, so v by 2l, that is the fundamental frequency, right? So basically this is n into f naught and this is n plus 1 into f naught. If you take the difference, okay, n plus 1 f naught minus, so n plus 1 minus n basically, right? So you'll have f naught. Okay, so n plus 1 f naught. Okay, so f naught you can take common, n plus 1 minus n. So n gets cancelled, you're left with f naught. Okay, so it is the difference between these frequencies, right? So f n plus 1 minus f n. So what is that? 450 minus 315. Okay, 300 if you remove 150, you will have 150. 150 minus, I think it should come around, so it can't be about 200. Okay, it can't be 150, lesser than 150, so 105, I hope, right? So 300, and if you remove 15 from there, what is happening? 150 and 15 from there. Okay, so I think there is a mistake in this question. I think this is 420. Okay, so this should be 420. Okay, so 420 minus 315 will give you 105, which is option D. Okay, so that's about these two questions. Over to the final question for the day. Then over here we have a string which is, suppose of length L, it is cut into three parts, suppose L1, L2, L3, okay, not uniform, may not be uniform. So L you can write as L1 plus L2 plus L3, right? So here I have given you half the answer. So this one, so the original one has fundamental frequency of n. These ones have n1, n2, n3 respectively. You are supposed to relate this n with n1, n2, n3. Okay, if you have seen the previously the formula of frequency, right? So far we have discussed the formula. You will see that each one is related inversely to the length, right? So in case of string also, it is v by 2l or v by 4l. It doesn't really matter over here. Okay, so it's not mentioned which kind of string. So basically f is proportional to 1 by l. Okay, this constants will cancel out on both the sides, right? So l you can write as, or if you, let's take this case, okay, you can do it with this case also. You'll see that the constants at the end of the day cancel out. So we know L, right? So L we will make a subject. Okay, so L will be V by 2F. Okay, F here they have used N. Okay, so L is V by 2F. So V by 2 N I'll use. So L1 similarly will be V by 2 N1. Here V by 2 N2. Okay, V by 2 N3. Okay, so here if you had chosen 4, it would have been 4, but anyways they are going to get cancelled. Okay, so it is 1 by n equal to 1 by n1 plus 1 by n2 plus 1 by n2. Okay, simple formula of this leads to this. Right? So the correct relation is option A. Okay, so that's about this video. I hope you really enjoyed it and you'll join me in the grind for 12 standard chapters in the next video, and that will begin in February. Also, I'll give you a perfect strategy for BITSAT 2025. Let's crack it this time. Okay, I'll give you from a 0 to 300 plus score strategy. Okay, so of course you should have begun by now, but even if you haven't, if you're lacking somewhere, okay, I'll give you a perfect strategy and you have to get working hard. Okay, pull up your socks and get on. Okay, so if you do that, 300 plus is no big target. Okay, and I'm saying it with conviction, and you'll find it in the video of strategy coming soon in February. So if you want to watch it, do subscribe to this channel or stay tuned. Okay, so that's about this video. Keep enjoying physics and keep practicing hard for your exams.